Okay. I'm not forgetting to do anything. I think I'm good. Okay, so um until we get a question, I'm gonna start off with the question just on the screen. Actually, no, can we do this right? I want the actual prompt on the screen too. I didn't think about that. Um, bam. There we go. Okay, and so first thing we want to do here is figure out where there's a boundary layer. We have some conditions that can not tell us for sure, but help us out here. Uh, so at the left endpoint, this a function is this function here that goes with y prime. So we want to check the left endpoint first, which is 0. That's equal to 1, which last I checked is more than 0. So boundary layer is possible. At the right endpoint, it's equal to 4, which is, I mean, it's not less than or equal to 0. This is awkward notation, but possible, no BL, and then we have to be concerned about the area between 0 and 1. Anywhere it's equal to 0 inside the interval, it's a potential boundary layer, but it's never equal to 0 between 0 and 1. Okay. And I guess we're just gonna, I need to scroll back up to the part A, because it's the same problem, just a different function or a different equation. Yeah, I guess we're gonna figure out our boundary conditions. So the outer region is gonna be the region away from 0, because that's where we think that the boundary layer is gonna be. And I want to translate these boundary conditions into boundary conditions for this like expansion. So when x is 0 and epsilon is anything, we want 1. Y0 plus epsilon y1. Epsilon squared y2. I see a Coldplay song in the queue. I'm getting rid of it, dude. Spotify. There's 2 Spotify songs. It's Spotify Coldplay songs. I don't mind Coldplay, but 3. Spotify loves Coldplay. I think Coldplay is 4. This is 5. Six, dude. How Spotify loves Coldplay. Okay. Anyway, so by equating coefficients, we're gonna find y0 is 1. Oops, not y0 of 0 is 1. Y1 of 0 is 0. 2 of 0 is 0, so on. Who cares? We don't need. We might not even need y2. I'm not sure. The other boundary condition at 1 is also 1. So I don't want to. I'm not going to rewrite all that crap. Same thing. What am I writing? Too many numbers here. Getting them all mixed up. Okay. And yeah, so now we can just plug in this series into the differential equation. So we get epsilon times y double prime 1 plus x in parentheses squared times y prime plus y of x. Equals 0. This one is way easier than the other one, isn't it? Oh no, I think it's about the same. I don't know. And then we want to equate coefficients based on epsilon. So for things without any epsilons, these all have epsilons. We're going to get a y0 prime 1 plus x squared. We're going to get a y0. Should label what I'm doing. This is the big O of 1 terms. So y0x equals 0. Now we can just, now we have just a regular old ODE that we can solve with our favorite method. So separation of variables is always a good, it's always a winner. Did I do this right? Yeah, probably. This integration isn't hard, right? It shouldn't be hard, but I need to do it separately. for whatever reason, I know it's just this use of. For whatever reason, I'm gonna mess it up if I don't actually write this out. 1 over u. Okay. I was gonna probably do a cubed, so that's why I needed to write this out. Okay. So 1 over 1 plus x plus c. And then we do e to the power of each side. Then I'm going to bring that constant down, call it c tilde. Okay, and then we can figure out c tilde. Oh yeah, so this is where we're going to see if it's actually a singular perturbation. It should be. We're going to consider both of our boundary conditions. We should get a contradiction. Should be able to fulfill both of these at the same time. Times e, so this implies e to the minus 1 y0 of 1 equals 1 equals c tilde e to the 1/2. C tilde is e to the minus 1/2. These can't both be true. And we know that a boundary layer is only possible at 0. So this first one is the one that's incorrect. So we're going to take the second one as our value for c tilde. So we get for y0, e to the 1 over 1 plus x minus 1/2. Now we do the same thing for y1. Or for epsilon to the power of 1. Back to the original ODE equating coefficients. So we get an epsilon y double prime, 1 plus x squared epsilon y1, and epsilon y1. Aaron, after 2 months you have a college entrance exam. You have basically cleared. If I go to study concepts, I feel like I should solve problems. I mean, that's the nature of problem solving. If it's easy, you're not solving the right problems. Just all you can do is just keep trying, and eventually it sinks in. If you only ever solve problems that are easy, that you're not really studying. Hey, Slim. Okay, so we know what y0 double... Oop, that epsilon shouldn't be there. We know what y0 double prime is. We can figure it out from there. Can we do a little shortcut if we... Thanks, Quant. I mean, honestly, this is easy enough to take the derivative of. Let's just do it directly. Y0 prime... Hope you're doing well, Slim. Derivative of that thing is going to be minus 1 over 1 plus x squared. Oh, it's going to be annoying very quickly. These problems are the worst. Y0 double prime. So now we have a product rule to do here. Derivative of this thing. Don't fuck this up. 2 on top. Get rid of the negative sign. It's the first part of the product rule. Um, 1 over 1 plus x to the 4th, I think. Disgusting. Okay. I mean, if that's what it takes, Aaron, that's what it takes. Like, are you just gonna not study? That's just how studying works. I don't know what else to tell you. Oh, of course, Slim. Hit me with a famous fun fact. Okay. So this is y0 double prime that we're going to substitute into there. And we get a very quote-unquote fun differential equation to solve. Actually, you know what? I'm going to divide out by the 1 plus x squared also. Oh, no, that's not cubed. That's to the 5th. So why would it be a simple power? I watch movies sometimes, but Peaky Blinders isn't too interesting to me. I didn't know that they're making a movie. You say, believe it or not, there is no place in the Bible saying that you shouldn't do Molly. Wow. Well, I've been holding myself back for no reason then. I gotta make up for lost time here. Ooh, I gotta flip my signs. You know that in Catholic school, there was warning me people were going to offer me free drugs and pressure me to take them, and that never happened, and I felt like I missed out. All right, I guess this is an integrating factor problem. I already integrated that once, right? I did. 1 over 1 plus x. With a negative sign, though. I'm not going to care about the concept of integration. It would cancel anyway in this next step. Be e to the 1 over 1 plus x. It's the minus 1 over 1 plus x times this stupid thing. Oh, we're gonna get some cancellations at least. This won't be the end of the world. That's a good question, Slim. Because I used to watch movies like a bunch when I was younger, and I haven't been super like I've only just kind of been getting back into it recently. It's like the last thing I watched is Ready or Not, a 2019 movie, because I saw an ad on Twitch because the sequel for it just came out, and the trailer in the ad actually got me kind of interested in the movie. So the advertising worked on me, as much as I hate to admit it. And it's a pretty good movie. It's like a dark comedy, um, horror-ish, but um, I enjoyed it. I I have a few movies on my list that I want to watch. Like I want to watch the Dune movies. Um. Oh, I also, the one I watched before that was Enter the Dragon, Bruce Lee's movie, which was, it was definitely cheesy, but I assume that movie kind of, it only feels cheesy to me because like every other movie is like copying it. It's a fun watch though. Hopefully I'm doing this right. I think I am. I think I am. I think I am. It is pretty old. Yeah, that's true. Yeah, I guess I was hesitating to call it horror because like I don't do well with things that are actually scary. Like I buy in way too much and I actually get super scared. In that movie, it's not very suspenseful. There's like horrific things that happen, but they're not like playing with your emotions and like trying to get you actually scared. So it's not like the type of horror movie that like I think of as like super scary that I would avoid. I'm not integrating this correctly. Yeah, I guess so. And it's like the horror is like not even just comedy. It's like it is like talking about like I guess like classes in society and like high class and low class people. So it I don't know, when I think of a horror movie, I think of like The Ring or one of those super scary movies that like scars you, and I would never watch one of those. Yeah, social commentary. I don't think it's a super deep movie as far as I could tell, but it still had like a message. I rolled P tubing. Well, what if I'm also P tubing Skirtle? I rolled this is like the sub differential equation that I'm solving right now, but it's part of a larger problem. Is P tubing? I'm imagining it like when you're I forget what it's called, but when you're riding in an inner tube in like a river or a lake or something, and you're having a boat like pull you along, but instead of water, it's pee or a catheter too. Is it? Oh, it's at my normal level. I only keep it to minus 30. There are actually lyrics though, which might make it more like distracting. I'll turn it down a bit. Yeah, I rolled. This looks concrete. It's actually not that bad. There's some interesting like concepts behind. It's called like a perturbation problem. Yeah. Yeah. Obi. In my differential equations class, it took us forever to actually start solving differential equations, but we're finally here, and we've been doing like perturbation problems, and it's pretty cool, like the types of convergence that you get. So many diamonds. Wait, diamonds. I don't know what diamonds you mean. Might just be you played Pew Pew games for 8 hours. Ooh, was it Overwatch? I'll figure it out. Oh, the VIP. Hot. I get it. You know, you were right, Central. You believed in me, and I did eventually figure it out. Thank you. You always believe in me. RGB gaming catheter. That just reminds me of one of those like silly straws that like it's a straw that you drink through, but it goes in all those like curly ways, except with a catheter and you're peeing. Foiled again. Okay, so which boundary condition are we using for this? Using y sub we're using no, we're using that one. Y1 of 1 is 0. This particular problem is probably from the Bender and Orsag asymptotic analysis book. The book we've been generally using for the class, though, is Peter Miller's. Okay, so we plug in 1. What do we get? This is 2 to the 5th, which is 32. This is... Ooh, nice, that cancels. 32 times 5. It's 160? No? Yes? Yes. Plus C. You know why you asked, fair enough. So this will be, if we get a common denominator, that'll be 5. It'll be 1. So 6 over 160 is equal to 3 over 80? Negative. Probably. Hey, collar cone. So we want all of this stuff. We want minus 3 over 80 e to the 1 over 1 plus x minus 1/2. All right. Probably should factor out the exponential, but who cares? The sure way to predict the future is to invent it. Yeah, that's true. It's not a bad fortune. Yeah, that's why they need to invest in your RGB catheter. Not bad. Color cone. Like, this is probably the easiest homework assignment we've had for this class all quarter. It's this particular problem is kind of a lot of work, but it's pretty easy to just like, or it's like figure out what to do is pretty easy. Um, I already went to office hours for it yesterday, and I need to go again tomorrow because there's debate about what second order actually means here and how many terms we need to go out to. And I really hope that we don't need to go out. We'll need to go out to 2 terms. Because getting the 3rd term is really annoying. But yeah, the unfortunate thing is that the same class is going to sneak in an extra homework assignment right as the quarter is ending, and we're not going to have the normal amount of time to work on it. And it's really stupid. So I'm trying to get this done as soon as I can, so I can have time to like get that done. Recently completed linear algebra. I mean, that's a great thing to know. It's really helpful. You had a literally impossible question in one of your homeworks. Did the professor assign it on purpose? It's kind of a dick move. Okay, we do need to analyze this thing around 0. We've analyzed it away from 0, but we need to analyze it at 0 because there's a boundary layer. You're coming with me for a minute. You know, that is one a question from a very popular functional analysis book. Huh. That's that sucks. We need someone to dissect a brain or separate the trachea from the esophagus. Oh, thank you. How did the body diddling or whatever go? I forgot. You mentioned that you were like gonna do that. We need to name a change of variables here. But not worth a 310-mile drive. Fair enough. Wait, when you drive a long distance, is it common for you to measure it in miles? That that seems weird. Not like kilometers? Oh. Have we talked about this before? I feel like people from the UK shouldn't even be making fun of Americans then for our units. Inday still got full credit for that homework. It kind of sucked to waste 2 days. Yeah, that's really mean. Color cone. Ace, hate. Joseph, congrats on the first. Yeah, that's true. Central. There's no shortage. Um. Okay, there's a certain way you have to do this change of variables, or like we need to choose this delta of epsilon function. And there's a way of thinking about it. So prepare for an exam that decides what college you get into. Ooh, good luck. Make fun of people from the UK for that monstrosity. Ooh, what is this? Oh, Stargazy Pie. I can see why it's called Stargazy Pie. You don't eat the heads, and the fish are boned to make them easy to eat. Don't bone the fish before I eat it, please. This is creepy. This is a kind of horrific thing to be served. They are. It's like, this is a real reminder that something like usually when you eat meat, it's like you, they're not like reminding you that something died to like make that meal, but this meal was reminding you that something had to die for you to eat that. Jeez, it's almost like a crown. A delicious crown. Damn, saffron? What am I, rich? Hard-boiled eggs? What the hell? Kim, thank you so much for the raid. I saw you were playing Ultra Kill, but I kind of just like got home and started the stream, so I couldn't watch. But Calcium Compadre, hey, welcome in. Thank you, thank you. I hope the ultra killing was fun. I'm allegedly doing math right now, but I'm on a tangent. I've just been taught that Stargazy Pi exists, and it's kind of terrifying. Oh, absolutely, nerd snipe me. You know, it's funny. The last time, you mentioned like you watched a video about Hilbert spaces, and literally the next day I learned about them in one of my classes. Yeah, no, absolutely. Like nerd snipe away. Links are turned on in chat, so feel free to drop whatever if that helps. I think I missed a message before the raid came in. It's just mackerel. I don't like most any fish to be honest. I think you waste time on that problem, not finding solution. It's not the same as wasted time. That's fair enough, Slum. Yeah. Fembox. No, these are mackerels apparently. This is a real thing in the UK. Let's see. You don't have the answer. A friend of mine doodled on a napkin at a party. Ace, I am a master's student studying applied math. So I enjoy like differential equations, mathematical biology. But yeah, I don't know, stuff like that. I don't like that much of like a niche that I'm super into. That this is a nerdy party thing. Okay, so e to the I pi is -1, checks out. Same with e to the 2 I pi, or e to the 2 I pi is 1. Yeah. Yeah, you can flip each side. Okay. It's apparently proof that pi equals 0, but it obviously can't be right. Okay, so ooh, what? Where do these +1s come from? At least on what step it's wrong. I mean, this part right here, this can't be true. Oh wait, oh no, I see what's happening. Okay, no, okay, yeah, this is okay. No, this would make sense. You multiply each side of these equations through by e. Okay. I mean, let's see if I can figure it out. But um, okay, and then we're multiplying each of these equations by each other. Shouldn't this be e squared if we're doing that though? Or no? Yes. Not multiplying, but raising. Oh, okay. So we're taking the second equation, raising each side to the power of 2 pi I plus 1. Okay, I think that step checks out too then. Uh, multiplying this out. 2 pi I. Yeah, okay. Huh. So that is weird. Um I would bet. I think there's sometimes issues with raising each side to a power. This might be one of those times. There's some weirdness with the exponent rules that's kind of unintuitive. I can never remember what the actual issue is, but color cone, that step comes from like this line here, multiplying each side by E. Hey, Aeneas. Okay, here. My head hurt more than that pie. Hey, I mean, there's pies here too. This line is very weird. Two pi I plus one. Two pi I. Oops. Is it apple? It's whatever you want it to be. I mean, I guess we did establish this thing on the right. That is E. I think it has to be this line. I need to remember like raising both sides of the equation to power rules, I guess. Like there's some weirdness. Like you can make some contradictions if you when you take two sides of an equation to a power. And I'm trying to find what the issue is. Yeah, usual. What I just wrote is how it came around. The person raised both sides to the power of 2 pi plus 1. I guess, Kim, is that the step that's wrong? The part where we raise each side to a power? What side's equation? The two terms. Okay. Maybe it's... Are there issues with doing I to the power? Like if we have... When we raise things to the power of an imaginary number, what happens? Um, maybe there's branch cut issues. I think the issue is that I could also do like plus 2 pi or 4 pi. E to 2 pi plus 1 minus 2 pi plus 1. I plus 1 minus 2 pi I equal to e squared. Oh, yeah, okay. I think I see what you're saying with there, Aeneas. Ooh, really slim. Maybe that's the issue, yeah. So, okay, we started with that. E to the minus 2 pi I plus 1. Slim is saying this is not equal to this. And I think that must be it. I don't know why though. Besides the reason that we're just seeing here, I guess. We can directly check it. Right, the left becomes e to the 2 pi I plus 1. Does it? Well, oh yeah, I guess because you could simplify that we said that this is equal to e, right? Interesting. So I guess the issue is that this exponent property that we normally know and love isn't, or I guess I should write the other part of it. This exponent property isn't true for complex numbers. Because I know the property does have some weirdness that I was trying to remember, but I think it was with like fractional exponents or something. Ask the AI. I mean it could be interesting to see what ChatGPT says. Um, but yeah, this has to be it. Exoplanet rules with complex numbers. Yeah, negatives and fractional exponents. Um, you know, I want to put my complex analysis book. Surely they talk about uh this the basic rules for algebra with complex numbers, right? What is this book called? Ablowitz and Focus. Find it eventually. Here it is. Leo, what's on the screen is a fake proof that pi must equal 0. And the challenge was to find the error in it. And I think we figured it out. I don't know how to pronounce that. Shy? Thanks for the follow. I think it uses a bad exponent rule when it raises each side to the power of a complex number. You have your finals in 2 days. Should you start I mean, if definite intervals are going to be on the final, you should probably study those. So pretty important in general. I don't know what your class is, though. Okay, presumably M and N are real numbers. All right, Shy, up to you. Explanation would be that to do that, so we're probably relying on the logarithm to be well defined. We have to choose the right branch of the logarithm. Yeah, it definitely has something to do with logs. Raising equations to a complex power. It is a cool problem, yeah. Interesting to see what goes wrong when we apply the usual isolated zero theorem to extend the exponent rules. Oh, really? Guy gave the problem as a huge nerd, worked at Google for like 30 years? Ooh. I've seen a... Oh, man, I forget what it was. I think it was a fake proof that pi equals 4. I don't know if I might be able to find it quickly. It's kind of a fun one. Let me see. It would have been... I think it was this one. Let me... Opening it up right now, though. Yeah. Oh, it's... Yeah, okay. That pi equals 4. It's from a real analysis class that Zach did on Twitch a long time ago. Okay. But yeah, it's a wordless proof that pi over 4 equals 1, and this is the, like, plot here. Has... That's a good question. I mean, probably about then. Yeah, that means he must have been there from super early on. How many hours of the day do you do math and physics? How do you not burn out? I don't really measure it, Shy. It's for me, it's just about like pacing, like study for a bit, take a break for a bit, study for a bit, take a break for a bit. 98, wow. So almost 30 years. You know some equality over the reals. You try to use isolated zero theorem to obtain the equality. Still to hold over the complex numbers. I remember you mentioned that theorem before. Oh, no. Why's my phone carrier texting me? And so you seen it before. It's very, yeah, I forget what the issue was. So you start with like the arc of a circle and you approximate the length of it with like a square, but then you can kind of like cut that corner in half and you get a better approximation. And then you can cut those halves in halves and eventually like it would theoretically converge to like a circle. But I think there's something weird here where it's like confusing area and perimeter. Like if you actually were to write out equations, it becomes a lot more clear why it's wrong. Oh, hey Zach. Speak of the Zach, and he will show. uh, yeah, this is actually from your real analysis class in the city of Amazingville. Yeah, Leo, we kind of did. It's just like also for Zach, we were looking at this like fake proof from Kim, or that someone showed to Kim that pi should equal 0. And we're trying to figure out where the error in the proof was, and it must be from this step here where they raise each side to the power of a complex number. And so basically, we've concluded that this property does not hold for complex numbers, at least if C is complex. And so this problem reminded me of the problem that you showed us. That's why I was like showing it. Where the line is always the same length until it's bent around the arc. Oh, okay, Jed. Yeah, it's been a minute since I've thought about it. The issue of interchanging integrals and limits. Okay. It seems wrong because you need uniform convergence to do that interchange. Your cousin Throckmorton coded? I don't know what that means. Throckmorton. Thinking after guys is in general, a to the b is generally defined as e to the b log a. And log is multi-valued. Yeah, that... Your cousin... Okay. Let's see. Your cousin Throckmorton. Oh god. Reading. Last book of the... Oh. Okay, so we're gonna have the actual problem. Throckmorton the skateboard? I want to see the full problem, though. Why is it only this fragment? That's gonna annoy me. No, you're mean. They never fail, right? No, that's all of it. Okay. That's a hilarious name though, Throckmorton. Like whoever wrote the textbook was just having fun. How many sides does the circle have? I mean, I guess infinity. Inside and outside? How true. My mother's name is Throckmorton. It's a beautiful name. Throckmorton lectures. Throckmorton sign pelvis? Did someone get it tattooed on their pelvis? Can you get your pelvis tattooed? Is it gonna load at any point? Is my connection secure enough? I I think I saw a dick. So... Sorry. Ugh. Is an X-ray? I guess it is a medical thing. Okay, you know what? I'm gonna hide the screen and then I'm gonna look at it. If someone's curious, they can follow the link for themselves. X-rays are allowed? Oh, okay. Um, why do dicks show up in X-rays? Oh yeah, I can see the balls too. I can't say I've looked at a lot of X-rays. Um, the Throckmorton sign refers to when the penis points in the direction of unilateral disease? That's okay. The more you know. Um, I hope I haven't missed chats. If I did miss someone's chat, I apologize. Maybe this guy's is Terminator? Maybe. Throckmorton sign? True. Um, this might be answering our question here, this article, about the complex powers. Yeah, I don't know. I'm getting too lazy to actually read this. Okay. I am gonna hide my screen before I open up this link. Let's see. Okay. There's no ghost dicks here. I just because it's on Wikipedia doesn't mean there's not gonna be like an X-ray dick. Conspirator against Queen Elizabeth I of England in the Throckmorton plot. Wow, there's a whole like Throckmorton cinematic universe. The stream is all over the place, but it's fun. The math doctors. Oh, and they have a cardioid. Haha. That's funny. Mm. I want like a 3 sentence explanation. I don't want to have to learn something. And I'm not getting. I guess you know. Actually, let's actually see what chat. I wonder if Chat GPT can figure this out. That actually would be fun. How does Chat GPT work? I I've asked it maybe like 3 things in my life. Uh, add photos. I need to download the photo. Save image. It's not saving. Yeah, it definitely has something to do with branch cuts. Okay, there's that. Okay. What is the error in this proof that pi equals 0? Let's see. Oh! Oh, it figures it out! That's kind of crazy. Oh, wait, no. No. It misunderstood that step. Never mind. What? ChatGPT? Oh, I thought ChatGPT winked at me and was about to take offense, but no, it's just a smiley face. Um, it misunderstood what the step was. Okay, never mind. I was about to have my mind blown. Quad is better? Probably. From ball and stick and an X-ray to... I mean, we're just looking up all the Throckmorton things, I guess. um... Okay. That was a fun question. Thank you for sharing this, Kim. So I was reading the paper of mathematicians trying to get proofs with ChatGPT 5. It's very impressive. Was there a paper about that? My life wouldn't be the same without Throckmorton. Same. Um, like, were they trying to figure out like what's the hardest proof ChatGPT could do, or what? Hashtag blame Jet. G hype. uh, maybe sometimes. Hope you're doing well, dude. We're talking about Throckmorton. We're looking at dicks and X-rays. I don't know. We're doing everything. Pi equals 0. If I try to understand this, I do the same thing. Plus or minus 2 pi theta. Yeah, because there's definitely other values of pi you could use there too, right? Especially if it's doing different tests to doing different test limits of ChatGPT for math. They attempt to see if it can deduce some results that it doesn't have in its database. Ooh, cool. Okay, I have to draw Throckmorton. There's so many Throckmortons to draw. We have to go with the original Throckmorton, though. Draw the X-ray dick Throckmorton. Oh, maybe this isn't part of the original thing, but like, I think this is what we should draw. Timothy Gowers. I don't think I know who that is. For my next hot tub stream. If I had access to a hot tub, I think it would be hilarious to do a math hot tub stream. It's him, my cousin Throckmorton. Combinatorics harmonic analysis, and it's very tall. Ooh, 3 impressive things. I am doing well, thank you. Okay. I've been meaning to rename this redeem back to being math only. I keep forgetting to do that. Because I don't think I've ever once done it while I've been playing games. Okay, see ya, Leo. Thanks for hanging out. Oh god, the skateboard already looks like a dick. I'm just seeing dicks everywhere. You know, okay, no, that's... It's just... There's no way to draw and have it not look like a dick. We should just embrace it. When am I making this pie? Never. I don't like fish. Embrace the dick. We want a cooking stream? It's possible that I'll do one over my break. I don't know. Skirtle's been requesting a cheesecake for a long time, and I might finally follow through on that. Definitely not making a Stargazer pie, though. Hey, you know what, Central? You're easy. See? You are. Me too. Me too. And also, I've made pies on stream. I have challenged myself. I like cheesecakes though. Cheesecakes are delicious. Okay, how do we start? Dude, this is such a weird pose to draw a person in. Replace the fish by goldfish. That would be hilarious, Color Cone. That's an idea right there. Maybe not that good. It probably wouldn't taste that good, but Boss Scans, thanks for the follow. Joan Hill character on Superbad? Oh, Superbad. Yes. I remember that was hilarious. Oh yeah, Slim, I just got your message. We can look at this paper once I make my flawless drawing. You clipped it? Okay. Clip it and ship it. Okay, Superbad is such a funny movie. McLovin! I guess we'll go from bottom to top here. Let's start with the shoes. Central's always here for the bikini stream. He's always hoping. Oh god. Oh god. Change my name to Throckmorton should guarantee a life of inexhaustible. It really would, Aeneas. I think it's a great idea and you should do it. I'm gonna make him orange because I don't have a better skin color. He's gonna have a spray tan. Throckmorton. I do feel like Throckmorton is the kind of dude who would have a spray tan. It's gonna be terrible. I'm building the base of a mountain that's gonna collapse. I don't know. Showed you have the pie I'm making? I already closed out of that tab. I don't know where the link is anymore. Does it have a hole in it? That's It's not a political statement. That would be funny, but no. Ugh. You know what, Central? You definitely have Google. You can always drop a link in chat too. I'm busy drawing Throckmorton. I should just color that in. You know what? That's true. Central. My bad. You know, I could have opened up. Who was it who linked it? It was Colorcone. I could have just looked up Colorcone's chat history, I guess. Oh, this song's a throwback. They used to play this song like every day during the high school announcements. They loved this song. Maybe I should make my last goal to make that last goal the most popular one on my channel. Is it me talking about dicks with a skateboard? I should just embrace the dicks. You know, I wouldn't mind. I love fish sticks. Convergent evolution of the mackerel to become streamlined in order to balance pressure, drag, and skin friction. Oh, wait. You know, I don't think I want to know Central. I need a good saxophone color. That's about as good as I'm gonna do. Oh wait, that's just orange. That doesn't look anything like it looked like in the color palette. Oh, that's because it chose the wrong thing. Oh, I hit cancel. That's why. Instead of okay. There we go. There. Uh. Okay. I mean I don't know what you're doing with those mackerels, Central. It's a free country. Just leave me out of it. That's all I'm saying. I can imagine you're doing things with them. uh, I made him a little pudgier. I was about to do him dirty there. He looks kind of pudgy. Oh well. Throckmorton lives life to the fullest. He doesn't have time to be on a diet. I think his thumbs go the wrong way too, or that at least the one thumb we can see is going the wrong way. But it's okay. Uh, it, his saxophone isn't quite reaching his mouth. It's okay though. He's closing his eyes. Okay, we just need his helmet, and I think we're home free. Throckmorton always remembers to wear his helmet. He's very concerned about safety like that. This looks like a beret. Perfect. We're the land of the free, except for 3D printers. The Jonah Hill version of the thing. Okay, yeah, I won't show that on stream. But yeah, Slim did draw the Jonah Hill in Superbad version of Throckmorton, which is, instead of a person here, just imagine a dick. One for his one for the points in direction of utilateral disease. Okay, I think this is my flawless drawing here. Thank you for the redeem, Jed. We're learning so much today, like about Throckmorton. Okay, Slim did share this article about using ChatGPT to try and discover new things. I just wanted to quickly see what it's about. Case studies in which GPT-5 produced new concrete steps in ongoing research across mathematics, physics, and astronomy. Yada 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 yada. AI started their work where it fell short. We see 4 new results in mathematics, carefully verified by human authors. I think Colorcut might be talking about the other masterpiece, not this paper, Slim. But if page 32 is the interesting one. A compact subset of L2. Syntax, it probably... Haha, I get it. I hope your expected value is 100. Or 1, maybe, depending on how you're measuring it. $31? Oh, the Timothy Gowers thing. So it is helpful to figure out if you're not being original and your thing has already been discovered. It shouldn't be too hard, but take a bit of time to solve. GPT. So for well-defined sub-problems, ChatGPT is decent. Or for asking about an idea to solve a problem. It's not good with open-ended questions or sketchy ideas for proof attempts. So my ideas do indeed work, and we'll write something that supposedly fleshes out the ideas do not withstand close scrutiny. It's the AI is programmed just to kind of agree with you, yeah. Ooh, yeah, geometric distribution. You can interpret it as like the binomial distribution, like the first time you get a success, maybe? Or if I remember right. Wait, so Colorcone, are you asking about the dick drawing or about the paper? Because I think you and Sim might be talking about 2 different things. Okay, yeah. You have to ask him to DM that to you. Or I guess I could forward the DM, but... That one isn't posted. Oh, good. Okay. I'm glad you'll have that to enjoy in peruse. Um, Problem then that's what distribution was. The help question was just a computation. Okay. Okay, this math is probably a little bit beyond me. I see Banach space and stuff. I do like this though, like finding AI's place in research, because it's gonna have a place whether you like it or not. We may as well try to establish where you should and shouldn't use it. Annoying shift in it, which I might have screwed up. I think I'll get partial credit. +1 or -1 will always get me. Yeah, with like starting counting from 0 or not. Notice at the beginning are insightful. Okay. Yeah, it's always a really annoying thing with translating real world problems into math problems, like where you set 0 and being consistent about it. Oh, the beginning of page 31. Okay, okay. I already read that piece. Okay. I might go back to homework problems, but this is like an interesting like premise for a paper. Because yeah, like I do really like this like breakdown of what it was good for and then what it was bad for. Yeah, the actual like problems here, I don't know if I'll be able to follow them. Simulations and programming has definitely been changed through the use of AI. Yeah, and it'll probably just continue to be. Power spectra of gravitational radiation from cosmic strings. That just sounds awesome. I don't know what it means. Well, I know what a power spectrum is, I think. I know what gravitational radiation is. Cosmic strings, I don't know what those are. Oh, well, okay. Just read the first sentence. Hypothetical one-dimensional topological defects that might have formed at a cosmological phase transition in the early universe. In the geometry of space-time? Like the topology of what? I don't know. Who cares? For no particular reason, I self-studied number theory. I need a book and exam time to do it now. Oh, so you can actually like get credit for it? That'd be sweet. That happened to you once? I don't know what you said that in context about. That pretty much theoretical physics sounds cool, but no idea what it is. I mean, yeah. These are some cool words. Like, if I was writing like a sci-fi like book or movie script or something, like I would borrow this language. You have to gather the cosmic strings to make the infinity guitar, and then you pass an expert level Guitar Hero song, and half the population turns into dust. That's my movie. So I didn't see new ideas just for the early universe without proper research. It's going to be hard to research. Yeah, I mean, that's like one of the hardest things to figure out. Just like how the universe started. If we ever do, that'd be pretty amazing. Cosmic strings hypothetically did stuff in my one-dimensional topology. Cosine it. Okay. Okay. Anyway, I do think I'm going to give this paper a rest. Ooh, it's a cool looking PD. Okay. I'm going back to perturbation for ODs. We can do it with a bunch of classes. We can do it on uni PCs. Thing is, I can do it at almost any university in Finland. Like, take the exam to pass out of a class? What? Oh, I'm still writing in blue. There we go. Wait, so would that count as credit at nearly any university in Finland then too, or just at your current university? Um, I think it's gonna be delta of epsilon equals epsilon. I need to remember how this works though. Same system, different exams for people from different schools. Oh, huh. That's kind of crazy how it's integrated like that. Part is moving to go to another uni. I'll be visiting often, so I hope I can maybe utilize some time there. Ooh, yeah. Yeah, I don't think we have anything like that. I mean, the closest thing, well, it's definitely not integrated like that is. You can take courses outside your university, and if they feel like it, they can accept those courses for credits. But it's not like it's a very like individual thing. Better to do it nationwide since Finland's small enough to do it. Yeah, or I mean, like, yeah. Cool. I'm just gonna say that delta of epsilon equals epsilon, so I really don't feel like thinking about it that hard. And I think it does give the proper balance. Because we want, as epsilon goes to 0, we want these two things to behave about the same, and that would give us what we want. Wait, what's happening here? Uh, Oh, this is a well. Okay, first off, this is supposed to be a delta. My handwriting isn't very good though. Let me back up. So the task is, um, we have this ODE with boundary values. But we have this number epsilon here that's just a parameter. And we want to get a series solution for this ODE just to like approximate it. And the series is actually going to be in terms of epsilon, not in x. Because we're kind of interested in how this thing behaves for small values of epsilon. And like that, the weirdness happens here because if you literally set epsilon to be 0, the differential equation becomes like, it stops being a second order and it starts being a first order. So the behavior changes dramatically if you actually let it equal 0. So you get this kind of, I might be able to pull up a graph of it, but if you solve this ODE for like progressively smaller values of epsilon, like 0.1, 0.001, 0.001, you'll get like a series of like, say this is the true solution if epsilon actually equals 0. You might get like this sequence of functions that has some kind of interesting behavior like this, where they kind of, well, let me draw it not as well first. It's like, maybe that's like epsilon equals 0.1. And then as you go smaller, it's a little bit better. And then like better still. But like you have this weird thing where at this point it never like quite converges. It just kind of sticks there. And that weirdness comes from having the epsilon at the second order term. If you make your boundary conditions just right, you can make that weirdness not happen, but that's kind of just by luck. But yeah, and so actually I shouldn't have deleted that. So how you think about it is you get if you're interested in the area between like 0 and 1, you get a series solution like in the area around 1, and then you rescale the problem and look just at this weird area around 0. And that's what that delta of epsilon thing is doing. Hey, energy. So I'm taking my original small x variable, and I'm dividing it by some function I haven't figured out yet in terms of epsilon. And that's going to rescale the problem to kind of like widen that area of rapid change out and make it easier to analyze, basically, or something like that. Limits? Yeah, sure. Yeah, just let me like finish up this little bit about what syntax has, and then we can talk about limits. So yeah, the thing is, you don't like how you exactly want to include epsilon in your change of variables depends on the differential equation itself. So far in our class, we've only really seen just like letting it equal epsilon itself, maybe square root of epsilon sometimes. Yeah, I think that's what I wanted to say. I mean, maybe I feel like I'm forgetting something, but yeah, I guess that's the reason why we need to analyze different parts of the intervals separately, and then the process of bringing those approximations together is super weird, and I can follow the procedure. I don't really quite understand it though. Okay, so Energy, you wanted about limits in math. So, just speaking intuitively, not formally, a limit is how a function behaves. A limit tells you how a function behaves around a point. So if I draw some random function, it doesn't matter what it even is. I'm not going to care. Well, I will care about the scaling. I'm just going to kind of make a random squiggle though. And let's say we want the limit of this function. We're going to call this function f of x. Let's pretend we want the limit of f of x as x approaches 2. This is the notation that we normally use to talk about limits. So given some function like this, your functions don't have limits. We're interested in how f of x behaves around x equals 2. So x equals 2 is this vertical line right here. And this function is really well behaved around 2. Like, there's nothing weird happening here. It looks like it's about 1. So in this kind of like quote unquote easy case, we can just simply say that this limit is 1 just by looking at it. We need to make sure that like it looks like it's heading towards 1 from each side, and it is. I'll show you a weirder case next. I've talked to Energy about math before. I think Energy is like maybe learning calculus for the first time, or has been for a while. Level 11. um yeah, calculus is awesome. Okay, so let me draw a different function now. I'm going to draw what's called a piecewise function because it's going to have a jump. Let's say when it's x is less than 1, it looks like this. When x is greater than or equal to 1, it looks like this. See, the actual definition isn't too important because we're just doing this visually for now, but just to show that we can say what this function actually is. It's equal to 1 when x is less than 1, and 2 when x is greater than or equal to 1. So if we, the interesting place to take the limit here is right here where x equals 1. We could do it anywhere we want, but like these limits over here or here would be considered like boring. There's nothing to think about. If you want limit as x goes to 3, it's just 2. So let's think about the limit as x goes to 1 here. And the issue that we run into is that as we approach 1 from the left, it looks like we're heading towards a value of just 1. And as we approach 1 from the right, we're getting a value of 2. So that's that's a conflict. We have two possible kind of results for this limit that don't agree. So this is where limits kind of break. We would say this limit does not exist, or DNE for short. Yeah, and so, but like just because there is a jump doesn't mean. Sorry, this song sucks. I'm gonna skip it. Uh, just because that there is a jump doesn't mean the limit can't exist. So if I can throw yet another weird one here. It's not too important what the function is. Just do a parabola for variety. So I'm gonna draw a normal parabola, except there'll be a little gap here, and then it's gonna continue on its merry way. And right at this little gap, I'm gonna manually define it to be 1. So if I were to actually write out the definition for this function, it would be x minus 1 squared if x is not 1, and it will be 1 if x equals 1. And so again, the interesting place to think about here is x equals 1. So long as x goes to 1 of this function, well, from the left, it looks like it's headed towards 0. The Beldum, thanks for the follow, and hey, welcome in. So yeah, from the left, it looks like this function is approaching 0. As we go to 1 from the right, it also looks like we're approaching 0. So this one actually comes out to be 0. It does not care that there's this jump here, because we don't care where the function is exactly at that point. It can be anything it wants. We care about how the function behaves around the point. That's the important thing with limits. Like, we don't care where the point is itself. We just care how it is around that point. And see, I'd say that's the intuition for what a limit is. There is a formal mathematical definition, which is called the epsilon delta definition of a limit. It's kind of difficult though. And it doesn't help necessarily with this intuition piece, which I think is more important for most people. Okie dokie. No, I haven't. My parents really emphasize getting good grades. I think I've gotten an F on one test ever, and that was for a music class, and I didn't care about it. I don't know if I even answered like all the questions, to be honest. And that was in like, I don't know, maybe 7th or 8th grade. What happens if you did, or is that a typo for me? Or like, are you asking about yourself or about me? But I don't know what happens if you do. I mean, hopefully you have another chance in the class to get a passing grade. I don't know. I'm sorry if you did. I don't know. I guess figure out if you still have a chance to pass the class and figure out what you need to like accomplish. I don't know what else there is. Oh no, the world will not end. It's maybe a setback, but like there's always a way forward. No. People fail tests. Like it happens. and they're still alive. um so yeah, energy, this is like what a limit is. um Let me know if you have a question about this. And I guess I the normal way that we calculate limits, unless it's something tricky, or there's a lot of tricks that they can throw at you, but to actually calculate one, like if they give you the limit as x goes to 2 of, I don't know, x squared plus 3x, as long as there's nothing special happening inside here, like division by 0 or some weird like piecewise stuff that we were looking at here, you can just plug x equals 2 right into this thing here. So 2 squared plus 3 times 2 will be 10. If they give you something like limit as x goes to 0 of 1 over x, then things get kind of interesting. Okay, yeah, and so that's exactly what we're asking about. So we can talk about that next. So yeah, maybe let's start off with all of their office hours. Hopefully, they understand it's one of those 0 BS people, though. Oh, yeah. I mean, I hope is there still enough time? Like, hope there's still enough wiggle room to like do well on other tests or homeworks and do well enough in the class. But I don't know. Like, I have that same fear of like not doing well in my classes and like what's going to happen. And at least when I do have those thoughts, I just kind of tell myself like, people have failed this class before. There's gonna be some resolution or some way to figure it out. Like, you might have to do extra work to make up for it or something, but there will be a way. Okay. So limits to infinity. Shining it everywhere else though, it's everything but math. I mean, hey, that's not bad then. Just one thing. Okay, so I guess first off, for a limit to 0, it's the same thing as this unless you're dividing by 0. So nothing necessarily special about 0 itself. Like, we could have the limit as x goes to 1 of 1 over x minus 1. So so even without 0 here, the issue is that we're dividing by 0. So we have to do some extra like analysis here. I think before we talk about this, though, it might be better to talk about infinity. So if we have the limit as x goes to infinity of, let's just take x. The function y equals x is just a diagonal line like that. If we're taking the limit as x goes to infinity, we're interested in the behavior as this function goes to the right. Like when I was first taught, I was taught to think of it as like end bit behavior. Like, how does the function behave at the end? So you talk about like the right end or the left end. Right is infinity, left is minus infinity. And in the case of x, it just kind of goes up forever, and it doesn't really ever do anything else. So depending on kind of like your context, you might say it's equal to infinity, or you might It's not proper to say something equals infinity though. People will know what you mean. It'd be more proper to say it doesn't exist. But saying it's equal to infinity tells you, it gives you some more information than just does not exist. Like, does not exist is very general, and there's other reasons a limit might not exist. A more interesting thing for x going to infinity that'll help us with the x going to 0 case too. But let's think about limit as x goes to infinity of 1 over x now. So 1 over x looks like this. So as x goes to infinity off to the right, this function is heading towards 0. So this function is decaying. And while it never quite touches 0, it can get as close to 0 as you want. So this limit actually does come out to be 0. Another way to think it is like, if you do 1 divided by a really big number, you end up with a very small number. And we're dividing by bigger and bigger numbers consistently. So we just end up with 0. And so yeah, with limits to infinity, you kind of have to graph them usually. Sometimes you, depending on how the function looks, you can actually do some calculations, but for something like this, you kind of need to think about it intuitively or graph it. But yeah, the same function is an interesting one to think about for x going to 0 instead now. Oops. So long as x goes to 0 of this thing, well, we can't just plug 0 in directly. We're not allowed to divide by 0. Who knows what 1 over 0 equals? Well, but what we can do, x equals hard, y equals locked. Hey, hard locked. Hope you're doing well, dude. Z equals awesome. Spitting facts. So yeah, 0 is the thing we're interested in. And so what we want to do is look on either side of 0. So on the right side of 0, we're going up to infinity, like it's blowing up. It's never going to quite touch this axis, but it's going to get like just higher and higher and higher. Whereas as we go from the left, we're getting huge negative numbers. It's going to negative infinity. And so for the same exact reason as this case failing in the limit not existing, this limit also does not exist because we can approach it from 2 different sides and get different results. We wouldn't say equals to D&E, but if I were to make this, say, 1 over x squared instead, though, the function would look like this. Oops. And so now they do agree. And so the limit still doesn't technically exist because it's going to infinity. But it is like, at least they do agree now. And so it doesn't exist for a different reason, basically. It's behaving the same way on either side of our point of interest. And so just like we can think of this limit as dividing by really big numbers, giving a small number, the reverse is also true. If you do 1 divided by a small number, you get a really big number. And if you divide by a really small negative number, you get a really big negative number. And so it could even help for stuff like this is to make a table of x values. So like x 1 over x. If you plug in, say, 0.1, you're going to get 10. If you plug in 0.01, you're going to get 100. Let me see what your question is. To clarify, you're saying the majority of the time you calculate the limit by calculating the function. So they're going to graph the function? Yes. And you can build an intuition for this and not need to graph it. There's kind of some systematic ways of like when you see a new function, how you can approach it. But it's not always something that you can just directly calculate. You kind of need to think about how the function looks. And so a really helpful thing is to be able to kind of, you don't necessarily need to do actual calculations, but think about how the function would behave as you plug in smaller and smaller numbers, or numbers that are like closer and closer to your limit. If we plug in positive numbers that are getting smaller, we get bigger numbers that are arbitrarily large. If we did the same with negative numbers, the same thing would happen, but with negatives. The Futter, what's your question? So I'm trying to think of some other interesting examples that I can show you. So yeah, I guess Ollie, what's your question? Sorry, I'm trying to think. So like another interesting one to think about is limit as x goes to infinity of sine of x. So sine just looks like a wave. And so limit as x goes to infinity of this thing, it never really settles down on just one value. It's always oscillating between 0 or between -1 and 1. So it's kind of a weird one, because even though it doesn't like blow up to infinity, this limit still doesn't exist, because you can't really pin it down to just one value. Determine sinusoidal equations from a graph. Yeah, we can talk about that. So yeah, Energy, I might leave the explanation here unless you want to ask us a specific question. If you want to see some more examples, I can always link you to my favorite Paul's Online Notes. Which will have a lot more examples of this. But yeah, I guess let me know if you have anything that you want to ask about that I haven't talked about yet. Okay, so Ali, I assume that you're interested in, or like you've maybe seen this general form for a sine function or something like it. You have? Okay, cool. Um, so each of these constants that I've called A, B, and C control different um, aspects of how the sine wave gets graphed. So, I guess where do we start? Maybe D is the easy place to start. So D is just like a vertical offset. So if D is 1, your graph is going to be raised up by 1, like as your baseline. And so the sine wave could look... Actually, let me make it a little bit harder. Your sine wave could look something like that. Um, uh, so yeah, D is like this distance here. A is your amplitude. So you need to measure the distance from your baseline up to like the height of the wave, or the baseline to the bottom of the wave. It should be the same. So that's your A. So that's that's a quick way to get the two constants there just from the graph, just checking those two distances. The B and C are a little bit trickier. How should I describe this? I'm just working out in my head what certain numbers should be for this problem to make sense. Okay, if this is pi over 4, right where this peak happens, and this is 3 pi over 4, 5 pi over 4. Is that right? No, this should be... This should be 5 pi over 4, I think. And then... yeah, that might be better. Thanks for the follow, Dexter. If I have a Discord server, we can post like a screenshot if you want. Yeah, sorry, it's a little bit hard to like invent this off top of my head because I gotta make sure that the thing that I drew actually makes sense. Let me get a sip of water while I wait. Grade 9, good to know. Welcome in. So yeah, I'll wait to see you post a question then, and for now I'm gonna go back to doing what I was doing before, it's just like some homework. But as soon as I do see your question, I'll go back to doing that. Um, I need to remember how this part works again. Wait, what? I just looked at the same thing. All right, multiply it through by epsilon. Makes life easier. Yeah, homework help is fine. Okay, perfect. Let's see. Oh, nice. This is a good graph. Okay, so if you have a specific like, if you use specific letters for this kind of like generic version of sign that will make you feel more comfortable, let me know. But otherwise, I'm just gonna write it like this. Oops. That's like more like familiar. Okay. So the thing that we need to reverse engineer is a regular sine wave. Just y equals sine of x is going to start at the origin and then at, oh, this scaling is a little bit weird. At pi over 2, it's going to be equal to 1. It's going to look weird because of the scaling of these axes, but at pi, it'll be 0. 3 pi over 2, it'll be -1. Then at 2 pi, it'll be back at 2 pi. So that's like one period for y equals sine of x. So we can see this function, it's been vertically stretched. It's been shifted upwards. And it's also been shifted side to side because it's no longer starting from 0, 0. It's probably been like stretched or compressed horizontally too. We'll have to figure that part out in a minute though. So I guess where to start? I guess I think like we were talking before, I think I want to start with figuring out A and D. Because those are usually a little easier for me to get my head around at least. So in order to figure out D, is basically our baseline, we can take the highest point, which looks like 7, and our lowest point, -3, and we're going to take the average of them. So D is going to be equal to, 7 plus -3 over 2. That's just what an average is. So 7 minus 3 is 4. 4 divided by 2 is 2. So if I draw a horizontal line right through y equals 2, that splits this graph perfectly in half, like that. So that's good. That's one piece of the puzzle. Actually, let me keep this line here for a second. So then our amplitude is a distance from this baseline. So, like the maximum. So from 2, we can go up to 6. That's a distance of 4. So A is equal to 6 minus 2 equals 4. And of course, we could have also done that with the trough, or like, you know, the minimum here. It would have been the same. Why isn't it coming out to be the same? Oh, it's 7. Oh my gosh. 5. I keep seeing the label of 6 here, but I'm forgetting it goes up to 7. That keeps throwing me off. So yeah, if we would do -3 minus 2 is -5, and then you make it positive. Do I stream often? Depends how you define often. I'm a grad student, so I just stream when I have time. If I do have time, I'll stream math like Tuesdays, Thursdays, and Saturdays. But I sometimes miss days because my workload is just too high. If you're interested in math streams in general, though, it's not just me out there. There's a whole niche of us who stream math on Twitch. I think today... who else will be streaming today? I only see actual education scheduled to start in about 2 hours. But throughout the week, there's usually at least one person streaming each day at some point. Often multiple. Okay, so we figured out A and D. We just need to figure out B and C. So I always get a little bit mixed up with B. It represents frequency, and I believe that's 1 over the period. I might have that slightly backwards, and we'll have to figure it out together. This part of this type of problem always messes me up. What I can definitely tell you is 2 pi over b. Ooh, that sounds more right. Yeah. The period is equal to 2 pi over b. Yeah, that sounds familiar. I would have gotten there eventually by checking my work, but yeah. Thank you for saying that. And so how we can figure the period out is look for 2 corresponding points and measure their distance. So if I want to take like the peak, for example, I can measure the distance from this peak to this peak over here. And that's a distance of pi. So that's mean our period is pi. It's equal to 2 pi over b. And I guess I could multiply b to the other side. B pi equals 2 pi. Divide each side by pi. And so b is going to equal 2. Yeah, okay, so this graph has been, I think, compressed by a factor of 2. Horizontally. The last thing to do is to figure out C. And I'm going to verify the result that we get at the end here, just to make sure that I did this right, but... So C is, it's called the phase shift, or like a horizontal shift. If you were to take this graph and just literally move it left or right. So I would measure it kind of like, we expect sine to start at the origin. It's a little bit weird because we're shifted vertically, but this is our baseline. Oops. So my eyes immediately go to this point here. Like this would be our origin if it wasn't shifted, because it goes up from here. I wouldn't want to choose like this point here because it's going downwards. I could choose this point over here too to do this next part with, but there's multiple right answers for this. I'm going to choose this point though. So what we want to do is measure the distance of this like offset from the y-axis. So we want the distance from here to here, which is this is pi over 2, so half of pi over 2 is pi over 4, like minus 0.25 pi. So, and it's a shift to the left, which I think means positive pi over 4. I always get that part mixed up too. I think what our answer is coming out to be, and I'm gonna have to check this. 2 times x plus pi over 4 plus 2. And so if I plug in, say, x equals 0, I'm going to get pi over 2 is 1. 5 times 1 is 5, plus 2 is 7. So that's good news. Yeah, this should be right. And I can even do you one better here. If you don't know about the website Desmos, you should, because this is a really good time to use Desmos. It's just a very nice, clean, like, graphing tool. So 5 sine 2x plus pi over 4 plus 2. This looks about right. Yeah, so teacher, let's talk about it. Oh yeah, it's a really good website. It's like here at x equals pi, we do hit a maximum of 7. And then back here on the graph, at x equals pi, we also hit a maximum of 7. So this does seem to check out. Amplitude? Oh yeah, so the amplitude is once you figure out your baseline, like what D is, measure the distance from the baseline up to one of the peaks. So if this peak here happens at 7, so the distance from the peak to the baseline is 7 minus 2 equals 5. The same thing works with a valley. C to be pi over 4. Oh yeah. Getting C to be pi over 4, it's your horizontal shift. So you have to know, like, kind of where sine starts. It normally wants to start at 0, and it looks like that and goes up to a peak. So you have to look at the graph that you're actually given, and basically right before a peak, look for where it intersects with your baseline. It's a little bit difficult to like explain this, to be honest. There's probably a better way of explaining this that I'm not thinking of. But C is the distance from this point here to the y-axis. And so that's pi over 4 minus 0. And so the vertical shift of this thing makes it kind of weird to explain this. But yeah, it basically, like, I think there's like you're starting with your basic sine graph here, and you're figuring out how much C is how much you have to shift it left in order to get these starting points to like match up. So this starting point matched up with this starting point here. But again, like that vertical shift is definitely weird. um yeah, feel free to keep asking me like how I or if you have any questions. Yeah, do you want to post another one if you have one? um I do want to show you another cool thing about Desmos is say like this pi over 4, instead of doing pi over 4, I'm just going to make it a letter A, and this add slider thing pops up. So I'm going to hit that button, and now we can kind of like scroll around A and see what effect it has on the graph. So you can see it's like shifting it from left to right. It's just a really cool way to like visually see the effect that each of these things has on the graph. So I can manually set it to pi over 4 and we get the same thing back. Urxabon, what's your problem? Not in a rude way. What's your problem? And say you can do the same thing like this 2 in front. You can even do multiple letters if you want. But like, so yeah, if A is this number here now, I should maybe have made this B. It goes a little bit weird when you make it negative. I have a Discord server where you can post it if you want. Oh, that's okay. That's fine too. Okay. I'm gonna quickly read Urxabon's question. I think we're gonna end up doing this one first, but let me just um read through it and let me get a sense of what Urxabon was asking. Uh, that question looks really. I don't know, Urxabon. I don't even know how to start with that. Probably Fox Gamer. Yeah, no. I doubt I I don't think I can solve that problem, Urxabon. It seems like you're just asking this as like a for fun thing too. I'm gonna prioritize this because I prefer to do homework help. But I I I would say that I can think about it, but honestly, I don't know where to even start with that one. um. Okay, so all right, high school math. Oh, that explains it. Definitely has a competition feel. Okay, so Ali, this will be the same procedure. It's kind of interesting that they don't give us quite as much information on this graph, but we can still do the same thing. So a sine b x plus c plus d. Um. Oh yeah, and so I should say these parentheses here are really important. You it is like a little bit different to get B and C if the parentheses aren't there. I think it's easier if they are there, so that's why I put them there. Just remember that those parentheses are important though. Okay, good. Okay, so same thing. Let's start by getting D. So D is take the height of the peak, 14.6, and average it with the height of the trough. So 14.6 plus 8.2 divided by 2. 22.8 over 2. 11.4. Okay. So D, our baseline, 11.4. I'm just going to guess it's somewhere like that. Hey, Fox Gamer. Welcome up to the other side. Oh, like we're like the 12 and the 6. Those are the X values. We'll need those in a second. But D only cares about the height. So for now, for the sake of getting D, the only thing we need is the Y values. Okay, and then for A, again, it's the same thing. We take the distance from D to either a peak or a trough, whichever one your heart desires. I'm going to do to a peak. So 14.6 minus 11.4 is 3.2. Okay. Yeah, this song's pretty good. You know, this one, it makes us think a little bit because they only give us 2 points. Um, trying to think of how to explain this next part because it's definitely like this is a harder one than the last one. Okay, so I guess for B, so like you said before, the period is equal to 2 pi over B. We know the distance from this valley to this peak is 6 because I'm doing 12 minus 6. But for the period, we need it to be like the same type of point. Like we want to do trough to trough or peak to peak. So we can figure out the distance from this trough to this trough because we know that this is like the halfway point. So we know that it's going to be another 6 to go the rest of the way. So this entire distance is going to be 6 plus 6 is 12 for our period. So that's why I said this one was harder. We have to do a little bit of like critical thinking here. So now we just solve this for B. Multiply B by each side. And then divide by 12. So pi over 6. Okay. And the last piece of the puzzle is C. So again, we're going to think about like where does this sine wave kind of start? And my eyes go to this point right here because it's where the baseline intersects the wave, and it's on an upward like trend, like it's going up to a peak, because that those are the two things that we want. And so this is we want to measure the distance from this point back to the y-axis again. The thing is, we don't know exactly, like, we need the x value for this point, and we're not given it. But we can use the same type of logic as we did down here. And actually, I shouldn't have deleted that. We know this point is halfway between this 6 and this 12. So halfway between 6 and 12 is going to be 9. So that point will be 9 comma something. Who knows? And we don't care. Well, I guess it's 11.4 because that's our baseline. That's not important though. So we know the x coordinate of this point here, and that's like the thing that we need to know. So this distance is 9. Now this is a shift to the right. And I think for that we need to do minus when it comes time to plug in C. So I think for our result, we're going to say it's equal to 3.2 sine pi over 6 x minus 9, importantly, plus 11.4. And I made this a negative because it's a shift to the right instead of to the left. And I sometimes get that mixed up, so let's check this graph out in Desmos. Okay, yeah, so I got that shift right because the peaks about line up, right? At x equals 12, we get a peak of 14.6. Perfect. So yeah, looks like this is right. Yeah, Fox Gamer, this is what you would learn like kind of after geometry class. It's called trigonometry. Ooh, good luck with your pre-IB program. Yeah, no worries. Yeah, sine, cosine, tangent. You start off learning about triangles with those. I mean, you might be doing this in geometry class too, but like you start with triangles and then you move into these like wave looking shapes in circles too. Yeah, I guess for either of you, if you're new to the math niche on Twitch, it's not just me who does this. Here to challenge you for no reason. Hell yeah, Ren. Challenge away. But yeah, there's other people than me who do help streams like this, and so in about an hour and a half, Actual Education is going to be streaming too. He also dual streams to YouTube as well. Start off with points and lines and planes, midpoints, parallel. Okay, nice, Fox Gamer. These are good things to know. Um, I'm probably not going to stream for a lot longer here. We could at least... Oh yeah, that was a little drawing that we were doing earlier. We could at least try to think about Urxabom's problem. I don't think I can really make much of any progress, but... Copy... Oh, the list? Yeah, you can copy that or copy whatever you want. The list is like a little like... Not it's like it's a little bit out of date. Like some people on there aren't like super active these days, but I don't really want to like take them off. Yeah, no. You and anyone are welcome to copy anything from the stream. Okay, an illusionist and his assistant are about to perform the following magic trick. Locate a positive integer. K factorial plus k minus 1 balls numbered 1 to n. It's an interesting, like, k factorial plus k minus 1. That's an interesting number. Okay, the spectator arranges balls into a sequence as he sees fit. Assistant studies the sequence, chooses some block of k consecutive balls. Covers them under her scarf. Illusionist looks at the newly pictured sequence. Huh. So the illusionist can presumably see all the other balls and just not the ones that are covered. I mean, yeah, Fox Gamer, if you understand anything, you can. That means you can do it with ease. Okay, so presumably the assistant would want to cover up, or like, the ones that are uncovered need to say something about the ones that are still covered. Wow, this is very open-ended. We should probably start with a simple, like, what if k equals 3? Uh, 6 plus 3 minus 1 is 8. So let's say our sequence is human RNG's best RNG, right? Okay, this doesn't feel... Oh wait, this is two. We had 2 6s and no 3s. So the assistant can cover up 3 of these numbers. And the illusionist needs to guess the sequence in order. Wow. High school students are expected to be able to solve this? Compared to their, like, competition level high school students, but, like, this is not an easy question. 30-day 3-problem competition. Okay, that makes more sense. So like maybe is there an easier question we can answer? Like, is there always a sequence of 3 increasing numbers, no matter what arrangement? That would at least narrow down the possibilities. Actually, wait, no, that would determine it, right? If there's always an increasing sequence, there'd only be one there. But no, if we swap the 4 and the 2, that would mess up that conjecture. Hmm. Yeah, that's also increasing, isn't it? But we could also get rid of that one if we swap things around. So I don't think we're always assured that we have a sequence of increasing numbers. And decreasing would have the same issue. So we need to have some type of like case. Or maybe I'm on the complete like wrong train. Like what if I mean you could narrow it down if you like actually no you couldn't. I was about to say like you could always make sure that like the minimum number is in the middle and then you at least have a 50-50 shot for the other two numbers. I mean that would really be the odds would get way worse for bigger numbers though, and it could be on the edge. Music just stopped. Um, I think if k equals 2, maybe I started off too big here. If k equals 2, n equals 5. Translucent scarf. I like where your head's at. Wait, no, n equals 3. You're right. Thank you. Oh, well, okay, yeah. So let's say like 3, 1, 2. We'd be covering up 2 balls. Uh, so there's only 2 choices here. How would you communicate the order? You need to do cases, I guess. Like you could agree to always cover up the 1. And then based off whatever numbers remaining, communicate some type of message. Somehow. You can get rid of that. 6 possible arrangements, I agree, yeah. I guess maybe it might be worth it to write all those arrangements out. Uh Brain no work. Maybe? I think I got all 6, and I didn't repeat any. If it starts with 1, it's 1, 2, 3. If it ends with 1, it's 2, 3, 1. If it starts with 1, it's 2, 3. Okay, so you're saying, yeah, if you have a 1 on the left and the 2 things are here covered up, we've agreed that this will always be 2, 3. Okay. If it ends with 1, we can agree it'll be 2, 3. Sure. If it starts with 3, 2, 1. If the end is 3, it's 2, 1. That should work, yeah. I don't know if this would... That seems difficult to make work for higher numbers. That would get the job done, though. Hmm. I don't know. My brain's going in so many different directions. I'm thinking about like modulus, like, or doing like modulo or arithmetic, or like even and odd shenanigans. But it's not really going anywhere. There was some kind of smart way of grouping these. It sounds like our response idea is to make 3 different groupings. So maybe it's actually helpful to create those groupings physically here. 3, 2, 1. It ends with 3. It's 2, 1, 3. Oh, wait. Actually, does that work, Urxabomb? Because how do we deal with these last 2 cases? They both end with 2, unless I mess something up. So it's possible that I didn't write these out correctly. But I don't know if we can actually distinguish between these last 2. I like the thought. I didn't realize that we'd have issues here though. 1, 2, 3, 2, 1, 3, 2, 3, 1, 3, 2. I'm just doing this a second time to see if I got this right. Okay, so actually maybe an easier way to think of it, there'll be 2 permutations with 3s here, 2 permutations with 3 here, so there's 2 more permutations with 3s here. And it's got to be 1, 2, and 2, 1. Those are the only choices. One, two, three, 1, 2, 3. 2, 1, 3, 2, 1, 3. 2, 3, 1, 2, 3, 1. 1, 3, 2, 1, 3, 2, 3, 1, 2, 3, 1. Okay, so I did do this right. Yeah, I like the spirit of that. It feels right, or like the right idea. Um, huh. I think we need to go for some other grouping though. This number is so specific. K factorial plus K minus 1. I wonder if there's some fact we can figure out about that number that would be helpful. Like, does it always have a certain factor? Ooh. One day you'll get it, Raven. One, two, three, 3, 2, 1. Two, 1, 3, 1, 3, 2. 2, 3, 1, 3, 1, 2. This should be better. Ooh, or do we run into conflicts here? Let me see. Max Sylvester, welcome in. Beginning versus end and 1 or 2 or 3 can communicate. 2 times 3 equals 6 possibilities. Oh, okay, yeah, I see what you're saying. We do have 6 permutations and like 6 bits almost of information. So we do theoretically have just enough information that we can properly encode this. One day. And actually that is what Erksabom is doing with this technique. So if we start with a 1, we've agreed it's 2, 3. If we end with a 1, we agree it's 3, 2. If we start with a 2, we agree it's 1, 3. If we end with a 2, we agree it's 1, 3. It's interesting there's that. That's like a repeating thing. Actually, ooh, Erksabom, I don't think we have an encoding for this case here. So we can't start with a 2 or end with a 1. Yeah, right. I mean, I get the nice little like camera symbol. I doubt I could be a VIP in my own chat. It'd be funny. It would feel a little vain. Then you should always get an increasing or decreasing sequence of length k. So you can agree to choose such increasing subsequence, or if it does not exist, fall back to a decreasing one. That would be interesting if it was true, Aeneas. It does feel like you need to have at least an increasing or decreasing one. I think I was able to engineer one that didn't have any increasing ones, but I might have created a decreasing one by doing that when I was working on k equals 3. But you'd have to like be able to communicate that if you do fall back. And that means you have to like, you know, if it starts with like an even number or something. I don't know. You can always choose increasing. So for this one, we would choose three things. And there's an increasing sequence here and here. But I was thinking if you swap the 2 and the 4, there's no longer an increasing sequence. Yeah, oh, okay. And if it doesn't, okay. So you're not saying it always exists. But does the illusionist know that it's decreasing now? Can the illusionist tell by what's on the table? Not necessarily. We should have coffee for Minesweeper. I could be persuaded to do one anyway. Because I'm kind of planning to spend a bit more time thinking about this problem and probably wrap the stream up. And we could do a Minesweeper on the way out. Like, I wonder if we don't have to be married to increasing and decreasing. Um, is it possible there's some other way that we can communicate the order of a sequence? Not, it's kind of hard. I suppose for the remaining balls, the illusionist sees. Then can choose where the cover begins. Yeah. Hmm. Yeah, I don't know if it's particularly important. I was thinking that like um if we cover up k balls, then the illusionist can see k factorial plus k minus 1 minus k, which kind of cleans up a little bit. I don't know if that's particularly helpful though. Like, can we say anything interesting about this number? It's always odd, right? It's beginning because we need the strategy too. Yeah. Hmm. I don't know what I'm doing with this. I just like the symmetry of having the repeating number in the middle. Hey, Papadoria. This feels like a question that your professor might have given you. This reminds me of a Papadoria question. Uh, Machka? The number of possible scarf placements is always k factorial. Uh, I did not figure that out. Welcome back, Fox Gamer. I think that makes sense, Machka. Or is it k factorial minus 1? Maybe it's just k factorial. Competition named Como? Oh, okay. Um, I like the symmetry with this grouping. It's like, what would I do with this though? It's like, if a 2 is covered up, then we can always leave the 1 uncovered. And we can just agree that those are the cases there. And we can do the opposite here and leave a 2 uncovered. But then that breaks on this grouping here. Well, we can leave a 3 uncovered. Oh, okay, yeah. Okay, wait, yeah, I think I found my own version of an encoding that works. If you can leave a 1 uncovered for these, leave a 2 uncovered for these, and then leave a 3 uncovered for these. Yeah, this is an interesting one, right? It's apparently a high school math competition question. Especially matches up with a number of ways to arrange k objects, so that leads me to believe it has something to do with the relative ordering of the numbers under the scarf. Okay. If you swap the rows of numbers in the rightmost column, the columns will be distinguished by the first number in the... Oh, shoot, I might have rearranged the rows after you said that, because I wasn't paying attention to the chat. If you swap the rows of numbers in the rightmost column, let me see if... I haven't read the rest of the comment yet, but let me just do that. Columns can be distinguished by the first number in the first row. The columns can be distinguished by the first number in the first row. 1, 2, 3. Oh, okay, cool. Okay, well, for the next case up, it's probably not a... We'd have 8 factorial arrangements, so I'd rather not write out all of those. um, But yeah, I don't know. Now that I've noticed this like symmetry here, I I feel like I'm kind of fixated on that. Can we find it in bigger sequences? So, like, if we held this for, well, maybe let's take an increasing sequence, 2, 4, 8 constant. We have 5 factorial. We've covered, well, no. I mean, maybe. If we this is going back to the increasing, decreasing. How do we communicate? If we can magically always find an increasing subsequence. Okay, never mind. I'm not saying anything new here. This isn't a new thought. It would be cool if we could find some type of like arithmetic relationship between what's covered and what's uncovered. That's probably difficult to do generally, though. Just out of curiosity, or Xabama, if you're still listening, like, is there a solution out for this, or is it like a recent question? They don't post the solutions. Oh, okay. Damn. This is an interesting question though. Like, thank you for sharing it. I'm starting to get to my limit of uh wanting to think for now and wanting to turn the stream off soon, but I'll keep this going for a few more minutes in case someone has a thought that they're still working on that they want to share. What if you agree to cover increasing sequences such that you start with the minimum possible number? 124, not 248. And opposite for decreasing, starting with the maximum possible. We need to be able to figure out whether sequence should be increasing or decreasing. It's a good question. So if I had this thing here, I mean, what if I kept everything the same and just swapped the 4 and the 1 though? Oh, no. You do not kill mood at all. It's a really fun question. I just streaming math is kind of exhausting, and I always hit a limit where I can't think much more. So it's nothing to do with you. I think this question is it's more interesting than I gave it credit for when I first read it. Then cover 873. Okay. And it can't be 378 by convention. That would help us distinguish between the case where there's multiple possible sequences to choose, yeah. We haven't answered the entire thing, but yeah. Not every arrangement has a sequence of yeah. Or oh wait, actually no, that would be ooh, I guess that's true. I think we were assuming that there always would be, but you could do 2 1 4 3, like just like swap every pair of numbers, right? 6 5 8 7. Yeah, and that's basically the same thing that you have there, Machka. That's a good point. Damn. That really blows a hole in this strategy for increasing and decreasing. Say your brain is full information, you can't think straight, take a 5 to 10 minute break. Yeah. I that's usually how I do math when I'm not on stream. I kind of like work at it for a while and take a break, work at it for a while and take a break. For being on stream though, I try not to take breaks, which is kind of like my brain is going to crash eventually. We can encode at most k factorial times n choose k. I'm sure this is exact or only an upper bound. Yeah. I was wondering that too with the consecutive. I think for consecutive you multiply by n minus k? N minus k plus 1? Okay. It's just how the problem is defined, Fox Gamer. We don't need to think about n factorial because it's probably not going to come up too much. I mean, it could, depending if we want to think about like combinations of stuff, but you know, I'm going to post this question into the Discord. Also someone will take a whack at it. I'm doing that now before I forget. Interesting question. Apparently, my 2019 high school competition. Solution is not known. Or they don't post the solutions. Okay. Max Sylvester, thanks for the follow. Why'd you always be able to find some permutation of k subsequent numbers? Or like subsequent like increasing or decreasing? No. Machka provided a counterexample up above in chat. I'm not sure if Raven is still here, but Raven did mention wanting to see a Minesweeper, being too poor to buy it. So I think I want to do one of those. Some permutation of I plus k. Oh, you're saying something else there. And some permutation of k. Oh, okay, you're trying to always find the same sequence, maybe? Oh, I'm not sure. You always know what numbers are under the scarf, right? Oh, kid with the phone camera. I didn't even see your chat. Sorry if it was a second. So we could eat a math streamer. Cover k balls, you have k factorial minus 1 remaining. One less than all possible permutations of k balls covered. Some encoding from possibilities to remaining ones. Yeah. That's what we've kind of been trying to wrestle with, kid with a phone camera. Yeah, feel free to keep putting thoughts in chat. I'm going to do this Minesweeper here. Just for the funsies. But we'll probably wrap the stream in a few minutes. So if you have any thoughts you want to get them out soon. If you want to keep thinking about it, post it in the Discord, or if you're already in a million Discords, feel free to just pop in chat and ask me if there's ever like an update. My Discord isn't like the most active, so I'm not sure if anyone will want to do it, but it is a pretty fun question. There we go. Not bad. I plus k maps to some sequence 1k. Sure. I think I have something k factorial. K factorial less than or equal to k minus 1, k factorial minus 1. If 1 is less than or equal to k. Why is this helpful? If k factorial oh, there's an extra. Wait. Like that maybe. The PB an odd degree integer coefficient polynomial. Suppose x p of x equals y p of y for infinitely many pairs x y of integers with x to the 6 equals y. Prove the equation p of x equals 0 as an integer root. Ooh. Odd degree. Okay, so it looks like I wrote down that right. Oh, x not equal y. Oh, okay. Funny. Okay, yeah, that's that one seems crazy to me, Polidori. I don't know how you do that one. They always share 0 or something. I don't know. Memory's massive. Yeah, Machka, that's the real solution. Who knew that like magicians had to be mathematicians? I mean, there actually are people like that, right? It's like a magic show, but like they're really good at mental math. K factorial minus 1 is the number of possible places of the scarf. K factorial minus 1 factorial is the number of possible orders of the remaining balls. Hmm. Yeah, that um I don't know. Yeah, and I think that like Erxbom is like showing a way that that mapping is possible. Um that I guess there must exist some really clever mapping here. Hey Phobos, hope you're doing well. And yeah, Papadori, I'm probably not going to think too hard about that problem that you posted. I'm sorry about that. I'm not sure where you even really start with that one, to be honest. Odd degree integer coefficient. Huh. Fair enough. Yeah. And since I should remember to do this since we have had a few new faces in chat. In case anyone doesn't know about the math streaming niche on Twitch, it's not just me. There's other people out there who do this too. I was Actual Education. I think it's scheduled to stream in like 45 minutes or so. Since I'm coming to the end of my stream pretty soon here. There are dozens of us. Hopefully, Phobos. Fingers crossed. We need the exact mapping as we saw my. Yeah, I mean, it was still really helpful though, Urxabon, because it got us like thinking. Like you have to be really careful about how you map it. Because you could leave yourself in like situations where you can't determine the last few cases. Okay. I don't know. I think I'm out of ideas for how to proceed on this. This problem is like it's really clever. Like I wish there was a solution because I'm sure it'd be something that's like I wish there was a solution like posted because it would be an interesting one to see. But reduce that possibility starting with the lowest number on one side for what we cover up. Hey Tizzer. Yeah. Although if we're losing the increasing or decreasing convention, then we need to figure out how else we're going to talk about the ordering. Or like yeah. I'm not sure. I think I'm gonna start to wrap things up here though. Yeah, Ursula, thank you again for this question. Clonk, you will witness a special ceremony. Ooh, that's fun. I don't know, Phobos. That's been bothering me. Um, it's a very specific number. The only thing like, it leaves, once you cover up k many balls, you have k factorial minus 1 remaining. And so it must make for some convenient, or like, I guess what it does, it makes sure you have enough information in the remaining numbers that are uncovered that you could encode the rest of the information. But I feel like there might be something else that you can do with that number too. I'm just not sure. Hey, Suna, holy crap, it's been a minute. I hope that you've been well. It's going good. How about you? Man, people are saying hi like right at the end here. I feel bad like ending it. Getting into linear algebra again? Ooh. We like linear algebra around here. You have to sleep at any second now too? Okay, good. It is pretty late for you, isn't it? Problem that for arbitrary n, what is the smallest k? Yeah, true, Ursabom. I would bet that the number that we're given here isn't far off, if it's not exactly it. Yeah, Suna, I need to go and say hi in your stream too. That goes both ways. Okay, Tizzer, why does the limit definition use a limit instead of just taking h equals 0? Because it doesn't make sense to take h equals 0 exactly. I'll try and explain this quickly because I do want to head off. But the way the limit definition of a derivative works, let's just do a parabola because those are nice and simple. Is you have some point x you're taking the derivative at. This would help to actually write out what the definition is. Limit as h goes to 0, f of x plus h minus f of x over h. So this right here is f of x, and I'm going to draw it like far away for now. This point here is f of x plus h. And so this slope or this limit definition is the same exact thing as the slope of a line. Like you might have seen the formula like m equals y2 minus y1 over x2 minus x1. Same exact thing, but there's an invisible minus 0 here. And what you're interested in is the slope of this line as h gets really close to 0, as these points get really close together. And if you just plug in 0 directly, you lose all the information like about right next to x. You don't care about just x exactly. You care about how the function looks around x too. So that's why you want to do as a limit, because limits encode information around a point, not just at a point, but around it. Your life is coming back to you? Hell yeah. Feel so many people now I don't probably see when you're alive. Yeah, that's fair. I'm always really bad about keeping up with people. So yeah, Tizzer, I hope that helps. Think about that. That is a really good question, though. I haven't really thought about that exact thing before. Awesome. No worries. So yeah, if anyone's interested, this question is I posted it in the Discord if someone wants to have a copy of it to like keep on thinking about. I'll probably have it in the back of my head over the next like few days. I don't think I'll come up with anything, but this is a good question, and it got some interesting conversation going. So I do think I want to wrap it up here so I can. I guess it's a little bit too early for dinner, but like relax for a bit and then get cracking on homework. Responsibility is subsiding. You loved it to hear it. Responsibilities suck. Okay, so I'm gonna stream off here on Twitch. We'll look for a raid. Tizzer, Papadoria, and was here on YouTube. Thanks for being here. The goal is to be back on Saturday, maybe even tomorrow, depending on how my life goes.